Howdy there, my name is Seth, and I'll be talking today about the Ice-Albedo feedback mechanism in the context of global warming and climate change. Well, we all know what ice is, but what about albedo? Here, according to Google, albedo is defined as the proportion of the incident light or radiation that is reflected by a surface, typically that of a planet or moon. So essentially, if a surface is whiter and reflects more light, it has more albedo, whereas if it is darker or blacker in color and absorbs more light, then it has less albedo. So if you think about your clothing choices for the summer, well, you'll tend to get hotter if you wear a black t-shirt because it absorbs more sunlight and heats you up. Whereas if you wear a white t-shirt, you'll have more albedo and your shirt will be more reflectant and more sunlight will be reflected off of you, leading you to feel cooler in the summertime. Looking at the Earth, we have some incoming solar radiation hitting the Earth, but a certain portion of that is reflected back to the atmosphere, and that fraction of reflected solar radiation to incoming solar radiation is the Earth's albedo. So we can calculate that really quickly here. 100.0 reflected radiation divided by incoming radiation, 340.2. So Earth's albedo is 0.29 or 29%. Now, what happens in global warming when the ice caps of the Earth melt? Well, if you think about it, ice is white, similar to a white t-shirt. So the more ice there is on the Earth, the more albedo the Earth will have, and the cooler it will be. However, as the ice melts, the darker ocean is exposed, and the Earth will have less albedo, essentially like a black t-shirt on a summer day. And so this is what creates the negative feedback mechanism, because once you start with a warm Earth, then the ice will begin to melt, which will then make the Earth darker, which will then make the Earth warmer. So essentially, you have a loop that goes like this, and one negative result leads to another. The warm Earth melting the ice, which makes the Earth darker, which makes the Earth warmer, and so the cycle continues in a negative feedback. Now, this all sounds feasible in theory, but has it actually happened? Well, yes, it has. A recent study published in a high-impact journal showed some significant results that using satellite observations, the Arctic sea ice has indeed been retreating, and this has led to a decrease in albedo, which has warmed up the Earth, an equivalent of 25% of the effect of CO2. And so this graph here shows how, as sea ice cover decreases, just as we described above, the albedo also decreases, which is what gives rise to that negative feedback mechanism of a warm Earth melting ice, which in turn leads to a darker Earth as the ocean is exposed, which warms up the Earth even more.